Today the topic is Coulomb's law in vector form. Earlier we have discussed the Coulomb's inverse square law, and according to that F will be equal to 1 by 4 pi epsilon 0 into Q1 Q2 upon R square. But as you know, the force is a vector quantity, and in this formula there is no vector sign in the LHS or in the RHS. This is the reason the Coulomb's law is to be considered in the vector form, because the force is vector quantity. For vector form of the Coulomb's law, we will consider a three-dimensional axis system, x-axis, y-axis and z-axis. In that axis system, we will consider two charges Q1 and Q2. Their position vectors are R1 and R2. The force acting on the charge Q1 due to the Q2, that is F12, and the force acting on the charge Q2 due to the charge Q1 is F21. The displacement vector AB is considered as R12 and the displacement vector BA is considered as R21. Now vector OA, that is the position vector, is equal to vector R1. Similarly, vector OB is equal to vector R2. Displacement vector AB will be equal to vector R12, and that is equal to vector R2 minus vector R1. Vector BA is equal to vector R21, that is equal to vector R1 minus vector R2. Now we will find their unit vectors, and for unit vectors the vector itself is divided by its magnitude. So therefore the unit vector R12 will be equal to vector R12 divided by R12. Similarly, vector R21, unit vector R21 will be equal to vector R21 upon vector R21. Then according to Coulomb's law, force F21 will be equal to 1 by 4 pi epsilon 0 into Q1 Q2 upon R12 square. It is multiplied by unit vector R12. As you know, unit vector means the vector whose magnitude is 1. Therefore, by multiplying this vector with this, there is no change in the magnitude, but this scalar quantity becomes vector quantity. Similarly, F12 will be equal to 1 by 4 pi epsilon 0 Q1 Q2 upon R21 square. It is multiplied by unit vector R21, and therefore it is clear F12 will be equal to minus of F21. Then the another one, that is the continuous charge distribution. It will be very useful while we will discuss the applications of Gauss theorem. So the first one is linear charge density, and according to this, the charge per unit length of a conductor is called linear charge density. Therefore lambda, which is denoted by lambda will be equal to Q by L, and its unit is Coulomb per meter. Second one is surface charge density, that is denoted by sigma, and it is the charge per unit area of the conductor is called surface charge density. It is denoted by sigma. It is equal to Q by S, and its unit is Coulomb per meter square. The third one is volume charge density. It is denoted by rho. The charge per unit volume of a conductor is called volume charge density. Rho will be equal to Q by V, and its unit is Coulomb per meter